Good evening and welcome to the BS and Beer Show. BS stands for Building Science. Tonight we're going to talk about managing moisture with pretty good envelopes. So we're going to continue the Pretty Good House series here and talk about moisture management. I am Emily Mottram. I'm an architect here in Maine. I am having what I like to call seltzer beer, which is just off-brand seltzer. BS and Beer is an independent grassroots movement. We all volunteer our time, so thank you to our guests and our other hosts for showing up to make this happen once a month, and occasionally we have technical difficulties, so all apologies for last month. We will reschedule the design show. A lot of people were interested in that. We encourage you to start your own local groups, and I've been really excited to see some very successful in-person local groups popping up. I just ask that you don't copyright the name, but go ahead, start your own group if you need help. Lots of people have started groups, so we're happy to share what we do. You find the chat box in the bottom of the screen. People are already using it. Go ahead and click all panelists and all attendees, or everyone, so that everyone gets to see your comments. Introduce yourself, tell us where you're from and what you're drinking tonight. There'll be a video recording of tonight's show up on our YouTube channel and also on Green Building Advisor to continue the discussion. And last, we just want to thank our media partners, Fine Home Building and Green Building Advisor, for helping us make this happen once a month. I am going to kick it off to Mike to give some announcements.
Thank you. Or Emily, Emily added an announcement. Thank you, Emily.
You're welcome.
Most importantly, I just want to say I am drinking a drink I just invented. It's ridiculously hot and humid here, and I really wanted a Negroni, so I did whiskey, gin, and Campari, but I did not have sweet vermouth, so I filled in with San Pellegrino Aranciata, and it is my new favorite summer drink. It is
Nice.
delicious. Emily, announcements. Emily is going to be hosting a Women in Construction Training Summit through Construction Instruction, August 15th and 16th, live in Denver. And I will post that in the chat. And since tonight is one of our Pretty Good House series shows, I will also post a link to our book. Don't feel obligated to buy it, but please buy it. And while I'm at it, I'll introduce Neil if nobody minds. Joining us tonight is Neil Freidberg, who serves as Building Science Manager at LP Building Solutions, where he tests, which is Louisiana Pacific, for anybody who doesn't know, where he tests and researches the latest innovations in the building industry. He graduated from Texas A&M with a focus on architectural engineering, HVAC, and structural design. That really covers the range. Prior to joining LP in 2021, Neil worked at Owens Corning for 10 years as a building science leader and field application leader. And I actually just listened to your podcast with Emily, and I was thinking that there are a few people in the building science world who you only need to use their first names. One of them is Emily. If you say Emily, everybody knows who it is. If you say Christine, everybody knows who it is. If you say Joe, everybody knows who it is. If you say Achilles, everybody knows who Achilles is. So you worked with Achilles for 10 years? I
did. I reported directly to him. It was
nice.
It was one hell of a ride.
I bet. Do you want to tell us a little more about yourself, Neil, and what you're up to?
Yeah, sure. So more background. I come from a construction family, basically. I've been working construction since about the age of 12. I realized that if people can do what they were doing on paper, I could go to college, and I went and I was like, I won't be in construction, I'll become an engineer. And then lo and behold, I'm back in construction. And then, I always tell people building science, that you don't pick building science picks you. And that's what happened to me. So I ended up becoming a building scientist, where OC hired me right as I graduated, and it was A&M Kingsville. It's a branch school. And then, I've been getting into trouble from day one. So, you know how it is. And I am drinking Deschutes Blackview Porter.
Ooh, it sounds good.
It is a deliciously dark beer. I love
it. Nice. And we jumped out of order a little bit. Maybe Travis, do you want to mention who you are and what you're doing?
Yeah, sure. I'm Travis Brungard. I'm a builder at Catalyst Construction in Prairie Village, Kansas, which is essentially Kansas City. And I also run a nonprofit, BS and Beer KC, which has a meeting next week where we're visiting the world's largest passive house, which will be cool. I'm drinking my lunch because I worked through lunch today. I was working in a faraway job site, and so everything's a little bit off schedule, and I'm having after lunch coffee, and I'll get to beer later. But until then, coffee will do just fine. And our next not-for-profit event, the Building Science Symposium, is in Denver in October. So check that out at bsnbrkc.org.
I will put a link to that in the thingy as well.
Ben will be there. Come on, Ben.
Yep, I will indeed. I'm Ben Bogie, and this evening I'm doing a little moisture management of my own and having a lovely glass of ice water because it's like 90-something degrees and like 90-something% humidity here, and I need to play a little catch up at the moment with my moisture. So I'm a production manager for Building Performance Cooperative here in Western Connecticut. And looking forward to being in Denver with Travis here in a couple of months.
Nice. Neil, I understand you might have a presentation to help us kick off the topic, which is moisture and water and stuff like that.
Sure. So no presentation. I apologize.
Oh, no, that's okay.
But I'd be more than happy.
Informed by your people.
Yeah, no, that as was I. But I'd be more than happy.
We don't, don't feel bad. It's totally fine.
I look, you talk about moisture, you know, I deal with it every day. You know, I do WUFI modeling, I do mold analysis, energy, right? I've you know, as a building scientist, you deal with these worlds. You may not own any of them, but you deal with them, right? So I'm very comfortable talking about moisture generation, walls. I can even talk about one of like my pet peeves that builders don't ever look at when it comes to moisture management, right? So like, for example, we focus so much on that exterior wall because we're so focused on bulk water hitting a WRB and getting out, right? Rain screens. When we have a attached garage, we don't do anything for moisture management. And you're talking about heat-driven moisture, right? Which is like literally the biggest issue for permeance, right? So that heat builds up in the garage, transfers through the paint, gypsum, typically, you know, whatever insulation is there. If it's not closed cell, it's fine, you know, and then it goes through gypsum, paint, and then into the conditioned space, right? We do nothing. We don't treat it like if it's anything but an unconditioned space. And in my opinion, that is one of our biggest issues when it comes to these garages, because they typically are more than a single wall, right? They're not, on average, there are at least two walls attached to the conditioned space. And that moisture development, especially in hot, humid climates, builds up, sun heats up that garage space and drives moisture inwards, right? So that's always been an issue of mine that builders don't look at, but we really should deal with moisture there.
I'm impressed. Go ahead.
Randy Williams had an interesting post earlier this year on a garage that had a sub panel in it, that they were replacing the sub panel in the garage after only 2 years because of their hypothesis was it was because of the sub panel was at condensation and there was a lot of salt borne on the water vapor in the garage space because he's in a cold climate that was causing all of the lugs and everything on that panel to rust out. Yeah, in like 2 years or something like that. So I think we're seeing more and more of these issues, especially in cold climates, where you've got vehicles bringing in, you know, gallons of water as it, you know, as the vehicle sits there and drains.
Yeah, or and in garages, even though you're not like creating indoor moisture by showering and cooking and stuff, you are getting that. I love the name, and I can often impress clients when I pull out the word solar vapor drive or the term, you know, solar vapor drive. It's a simple concept but a cool name. I'm always surprised that builders don't use WRBs between cladding and sheathing on garages, like. Or like, why isn't that just as important as, you know, as the house?
So I've built a lot of houses and I've complained about a lot of pet peeves, and I've listened to the complaints of others, designers, builders, clients. this is the first time I've heard someone list this as their pet peeve. I'm impressed, Neil. This is a curveball, and it's got me thinking, because all the production homes that I built, way back in the day before Joe and I started Catalyst, they didn't even wrap Tyvek or anything over the studs. It was exactly as you described. Drywall at the interior of the garage, cavity insulation, drywall at the interior of the house. So the exact condition you're describing is something that I put into a lot of houses under my watch. This is before I'd even had a twinkle of my building science in my eye. It was just like earth shattering to hear you mention that. We kind of accidentally solved for that, not because we're so worried about moisture in the garage, but because we're solving for air control at the garage, and we're isolating for air control at that layer. We haven't obviously dealt with any of that, because, you solve for air, you generally are solving for most moisture. So, but I'm a little disappointed in me and appreciative of you for bringing that to light. Because I don't ever really think about that as, oh, I'm solving for moisture here. I always think of it as, well, I really got to worry about my air control here, because we have all this exhaust gas in here, and there's all these unfavorable smells from the lawnmowers, organic decomposition and all that. And I'm never, ever looking at it in terms of, well, the snow melt off the car is going to evaporate, and then I'm going to have all this to deal with, and it's the outdoor humidity, all of which is true. So bravo, sir. Bravo.
No, it's always been a pet peeve about it, especially in Texas, right? Because I lived in Texas, I moved to Tennessee. It's still kind of hot and humid here, but it's much cooler than like Austin or Houston, especially Corpus, where the vapor drive from the sun, and that basically a hyper thermal conductor metal garage door panel, adding to that heat, that radiating heat into that unconditioned space, right? But it also affects air sealing, indoor air quality. It affects all that stuff, product swell, right? Because one of my biggest concerns, especially in my world now, is we're always looking at mechanical failures of our material because of moisture. And a majority of that damage can be from vapor and not bulk water. So when we're looking at things like that, it matters. And then obviously the air conditioner, right? Are they designing with the assumption of moisture not coming in through that space? Because there's it's not a significant amount compared to a leak, an actual air path. Joe has done plenty of studies based on, that 1 inch by 1 inch hole, 30 quarts of water, one winter season, right? So, but you have probably, off the top of my head, 150 to 200 linear feet of, potential cracks where moisture can come in through air pressure. So, it adds up. I'm a big believer of controlling moisture, which controls comfort, because I'm a big dude, right? And I don't like being uncomfortable.
Even small people don't like to be uncomfortable, to be fair.
That's true.
Yeah, or we kind of jumped in. I wouldn't necessarily say the deep end, but maybe the middle. Let's back up a little bit, just for anybody who's not familiar with water. I don't know, or what is moisture control? Why is it important? Or just in the Pretty Good House book, we talk about the 4 control layers. Water control, air control, vapor control, thermal control, in order of importance. So water control is the most important, and I like the idea of thinking of it as layers, but that implies that there's like one material that's doing all the work, and so maybe maybe layers isn't the best name, because like when it comes to water, there's the WRB type thing that is the most important thing, in my opinion. But then we also need a cladding or something to keep bulk water from getting to that membrane. Do you agree, Neil, or do you have other ways of looking at it?
No, right. So bulk is key. Bulk is always key. Yeah. It is like I think last I looked up, like 75% of construction litigation is bulk water issues, mainly roof, but it's bulk water nonetheless. And then the rest of it is mold and mildew due to vapor drive, condensation, right? While I'm not a big fan of dew point analysis, I don't believe in static analysis because the world isn't static. I'm a big fan of like hydrothermal. like a WUFI analysis where you can actually, limitations understood, right? The program is not 100%, it's 75. And it takes some understanding on how to use it and how to interpret the information. But bulk first, then vapor is always how we should look at it, right? We want to keep that amount of water out. And then, in third step is also moisture generation inside the home, right? What it's being used for. Are they going to put an indoor spa in the middle of the living room? Or are they, if they're going to have 20 dogs or 20 cats, they produce way more moisture than humans do.
Yeah, the occupants are always
Yeah.
Well, that's not fair. We make a ton of mistakes as builders, but most of the simple things like make sure the roof doesn't leak, make sure that the windows don't leak, flashings, claddings, the WRB that Mike was talking about, the occupant behavior thereafter is a very important part of this. The clean gutters, the window being closed, maintaining caulking joints, like all these things add up to a whole lot of important stuff, especially when we start getting down to vapor. And then it's, did the cable guy come by and
poke a hole,
leave a nice hole in your house?
Yeah.
Or was the line set never properly gasketed and sealed? Did they just throw some thumb gum in there and drive down the road? All these things add up to a lot of problems. So I think it's Steve Rook that talks about the importance of drying over keeping water out, focusing on the potential for drying. And I'm not going to quote him because I'd botch it, but I will definitely say that there's a renewed focus on that as we've gotten our buildings tighter and tighter and tighter. Now we're talking more and more about how can we dry all this stuff out? If anything actually does get in, what are we going to do? And, dedicated dehumidification, all those other topics that are raised with that come to mind.
Peter Yost has a great comment about wetting and drying, where you have to think of it like a seesaw. Your wetting potential is on one end of the seesaw and your drying potential is on the other end of the seesaw. And you always just have to make sure that it's weighted a little bit more towards drying than it is towards wetting. But how to make those judgments on complex systems is difficult. And I appreciate your comment about WUFI not being 100% there, because it does, in my experience, miss the mark a lot, but it is much better than dew point analysis, because that one moment in time may only exist for a couple of minutes a year. And that doesn't show the real picture of what's happening inside of a building. I don't remember who it was that said it, but there's 3 things that kill buildings: water, water, and water. So
that's a good quote.
I thought you were going to say water, water, and people.
Well, to Travis's point, we can build the perfect building, and the worst thing we'll ever do to it is let somebody move into it. So,
or I think maybe the quote you're thinking of, Travis, is my pet peeve. As people say buildings have to breathe, and the fact is buildings don't have to breathe. People have to breathe. Buildings need to dry. And I will say I'll buck the trend. I'm pretty comfortable in that role. I actually like dew-point analysis because it's easy, and I feel like it's if you use if you use prescriptive code measures, I feel like it's pretty safe most of the time, and I can do a dew-point analysis in seconds to minutes. Versus WUFI, I don't even know how to do WUFI. I could spend a couple $1,000s and take the training and buy the program. I've played around with it, but it's garbage in, garbage out. I think if you're pushing the limit of things, then WUFI can definitely help you get there. Or if you have a very challenging situation, like say like a pool house maybe, where it's not a typical situation. But I think dew-point analysis in the IRC building code sort of prescriptive solutions are a safe starting point. When we're trying to get people to do better, we can't make it overly complicated.
I completely agree. But that's why I said I don't like them, right? Because I know better. But if it's the person coming in, 100%, that's a great reference. I mean, there is tons of, I'm like maybe average smart, like there's smarter people dealing with these codes, like building these analysis for us, right? Based on climate zones, based on everything else.
I want to put a plug in there for Glenn. I don't know if he's here, but if he watches this again too. I think they should take the vapor control sections from the IRC and add them to the IECC because I think a lot of people screw that up and they don't know they're screwing it up and they're creating an issue. I heard Christine say once that people say, like, what's my water control product? And it's like, it's not a product, it's a series of products and things that kind of all work together. And I think that is something that we forget. And the code, which is supposed to be the thing that helps us, I feel like doesn't always have it in a place that's easy for someone, because, you know, I don't know anybody that knows the code inside and out like Glenn does. A lot of us know a lot of the things that we use that are applicable to us, and those of us who study building science have done a lot with that. You know, I saw in the chat box people were saying, you know, vapor is our new enemy, and it is. And I think you're coming to water management from a building product standpoint too. And I think that we're asking people to do building science with all the new products that we put on the market without kind of giving them the backup they need to know what they're supposed to do with these products to make sure they're in the right installation, that they are able to dry or able to stay warm or cool or whatever.
You're very right. It's always, you know, internally we have conversations all the time. It's like, well, how much can we put out without actually designing? Because if we start designing, we could be considered liable as a manufacturer. But you're 100% right. Like, I would love to go out there and say, hey, look, this is how you do moisture control. This is how you do vapor control, moisture being bulk moisture. This is how you do vapor control based on climate zone, based on orientations, right? Because another thing that gets me is people focus on the full envelope, but on the north side, maybe a ½ inch more of a continuous insulation would prevent more moisture issues, right? Because that side doesn't see any heating, right? So that side can stay colder, can condensate more. Right? I don't like seeing a continuous solution if it's not properly analyzed, because it doesn't work that way. Houses are dynamic. Houses are their own system. We just benefit from being inside them.
From the field, though, I will say that you very rarely will find a plan set. Like, I've seen the wrong windows, you know, oh, we very specifically designed the solar heat gain on this side, but we went ahead and put those windows on this side because it was the same size opening and these were on the top of the stack. That happens. So if we can keep it simple for the people in the field and say, this won't have any problems anywhere, let's use that one product, that's always going to be better for those of us in the field who are trying to overcome the challenges of a less skilled labor force than we used to have, or at least a less attentive one. Although, you know, things are getting better out there too. I don't want to, you know, besmirch the good name of the tradespeople that are coming up. They're obviously at least average smart, right, Neil?
Yeah.
That's the best term. I love that. Can I use that? I think I'm about average smart too.
Yes, likewise, average smart. What's that, like IQ, like 120 or so? Is that
Bob Kelly brought up a good point in the comments about how he feels like we're seeing more and more of these moisture related issues nowadays. And I think that's something to be mindful of. And I don't think it has anything, well, let me say this. I don't think it's all product driven or anything like that, or tradesperson driven. What we've done is over the code cycles, we've ratcheted up the energy performance of buildings. And what happens when we ratchet up the energy performance of the building, we're lowering the drying potential of that building. So it's that seesaw thing. The reason we have old buildings that don't have failures is well, because only the good ones lasted. So they're the ones we have as examples. And also, like, they were leaky and poorly insulated. So if water got into them, there was plenty of heat and moisture flow to dry it out. So it's not that we're seeing disproportionately more failures now, it's that, you know, that the playing field is different, you know, and then you add into that all of these myriad of different building products that we have and assembly types and approaches to constructing a wall. Now, when I started in the industry, it was 2x4s, 16 on center with the Tyvek, and you made the X cut in the window and you folded it into the window, and that's it. Everybody knew how to do it. You don't see the same wall assembly on any two buildings anymore. So yeah, basically what I'm getting at is that it's changing, and we have to be really cognizant of dealing with moisture to the same level that we're dealing with energy, because moisture is fundamentally energy also.
Yeah, well, I completely agree with you, Ben. And well said, right? I don't ever want to diminish trades, because I never like referring to them as unskilled. Look, I can't take a hammer and hit nails all day. That's a skill. I don't care what people say. It is never easy. I used to, when I worked at Owens Corning, I actually learned how to insulate from the installers. Like I would go out there and do a lot of QC, and I would be bored. And so instead of sitting in my truck, they'd give me bats and stilts. I don't work for OC anymore, so I won't get in trouble. So I would get stilts and work on installing bats, and I would learn how to do a grade A or grade 1 installation because I had to go out and teach people. And then the next biggest barrier is the language barrier. I speak Spanish fluently, so it really benefits me to be out there in the field and talking to the installers who are basically told what to do but don't understand the what. And I think that's where we're failing our people. I can talk to a super all day. I can tell him why, but if he can't communicate that to the people actually doing the work, nothing happens, nothing changes. They do what I call the nod. They go, yeah, and then they walk away and go, man, what did he talk about? What did he say? They're like, I don't know, just do what you keep doing, right? So that's always the conversations I talk to people about when we're dealing with this moisture management conversation. The higher energy efficiency it's a step. It's if you're not taking care of all these steps to make sure you have a successful build that manages moisture, energy, right? HVAC sizing is a huge conversation when you're dealing with moisture, and people constantly love to oversize. They're like, oh, I got 5 tons. I'm like, well, you only needed like 3, right? And you talk to the installer and they're pushing that because they don't know any better, right? So we as an industry need to do better for everybody, from the guy literally hitting the nail, why he's doing it, why he's putting OSB or sheathing where he's the one who sets the air barrier for the home, right? And the structure of the air barrier, and then why the insulator has to put insulation and seal, and why the plumber needs to cut a better hole rather than using a hammer as a hole saw. You know what I mean? Like it's this continuous fail, because as we start failing the second we lay down that concrete. If they don't lay that plastic right, if they don't do the right for radon, if they don't do the right for moisture management. Conversations I've had with many builders are, why am I having these issues? And slab on grade, it's hard to see, but I can almost guarantee you that they walked on coarse gravel on the poly, and that led to a puncture where moisture is now penetrating through the cement, right, or through the concrete. All right, so all these things start adding up, and we need to quit failing our installers, the people who actually do the labor, and include them into these conversations on top of dealing with all these big things.
Yeah, to that point, Neil, everybody wants to talk about, different initiatives and lobbying for skilled trades and this, that, and the other thing. The thing that I continually say to manufacturers is we need you to make good pieces of information on how to install your products in short little tidbits, and they need to be easy to find. Yeah, that's the only thing that we're going to need. Like, as we bring new people into the trades, as we educate people on it, if we can't show them something on how to do it, and to your point, it needs to be in multiple languages, then we're failing them on giving them the information.
Yep. Yeah. So if you were to look up some of the new LP stuff we're doing, it's in English and Spanish, and I happen to be the person on camera because I'm the technical building science dude and I speak both, right? So yeah, but you're right. It's becoming more evident to us, even as a manufacturer, that the installers are the ones that matter more and more every day, because of the fact that we're failing them if they don't understand what they're doing and why they're doing. And this leads to moisture management, right? If we have siders who aren't putting in the right format based off our manufacturing, I'm going to have to be the bad guy when I have to do a forensic analysis or go out to the field and say, hey, it wasn't installed right? So they need to know why, how, and on top of it, they need to make sure that they're doing it right and to the code, right? To the standard of which is designed for.
Shout out to Josh Salinger, who's in the audience. We were watching a flashing video on Windows that you did today, and I said to my husband, we need to just have a QR code to link to these videos so that when they put it on there, they do it the right way. And so the fact that you guys are already making short videos like that, Neil, for your specific products or whatever, that we as architects and designers can put on our drawings that might make it easier. Just make me a little QR code next to it and I'll copy it so it goes there every time. But this is something I've said for a long time, and we talked about actually doing it today. And I think we're going to start implementing some of this, because I think you're right. When you're out in the field, everybody has a smartphone. Somebody has a smartphone on the job site. It's like, oh, wait, what is this thing? And then if they can get it in a language that they understand, that makes an even bigger difference.
Yeah, I mean, we're looking at putting QR codes on our products, and they're going to be linked to a video or a website where it's English and Spanish, and then, you know, they can click on which one they prefer, and it's going to link them to the same video, the same information, the same text data sheets in both languages. We're working on French, we're working on a couple other ones, but yeah, you know, it's the only, I will say that it's hard with Spanish because we have different people from different parts of Latin America in here, right? And their Spanish may not line up with, you know, the traditional Mexican Spanish, which is what I know, right? So if I deal with Guatemalans, they're a little bit harder. If I deal with Chile, throw my Spanish out the door sometimes, right? So it just depends who you're talking to.
Something you mentioned, Neil, that I wanted to touch on is HVAC systems, because part of that tidbit I mentioned about you know, tightening up on energy is we're getting into heating and ventilation systems that are much more efficient. And one of the ways that I learned recently that they're accomplishing this is that they're actually raising the coil temperatures in the air handling units, because it allows them to use less compression in the compressors and use less energy to run the refrigerant. And what that translates into is that the system may be properly sized for the sensible heating or cooling, but it doesn't have the ability to get the coil cold enough to actually remove moisture. So what we're also seeing at the same time is you know, the systems in their gain for efficiency are shooting us in the foot in the fact that they can't handle moisture anymore. We're in climate zone 5, and we are trying to specify on all of our projects dedicated dehumidification, because we're seeing issues with moisture control. Because in the warm season or in the shoulder seasons, the system's not coming down long enough, and it's made even worse if they are oversizing. Now we're short cycling, and it definitely doesn't stand a chance. You know, because your dew point analysis is based off of a set indoor, you know, conditions for humidity. And if our systems can't maintain that, then, you know, any of those analyses go out the window even more.
Yeah, 100%. I completely agree. So I'm gonna give an example. I worked with someone right before I left Owens Corning. We did buried ducts in his house in Austin, Texas. I think he said it's a 4,300 square foot house. His first month's full bill was like about $200 in energy, buried duct. And he calls me and goes, "Hey man, I'm really concerned. You know, we put that 3-ton unit like you recommended up, you know, upstairs, and it doesn't turn off." And I'm like, "Okay, don't be concerned. Units that run all day actually last longer than units that stop and start, right? Wear and tear." And he's like, "Yeah, but you know, I'm just concerned of how long it's running." I'm like, "Yeah, but you told me your energy bill's $200 for a 4,300 square foot house." I go, "And what's your temperature?" He goes, "Well, we like to keep it about 69." And I'm like, "Okay." I'm like, "What's your relative humidity?" He's like, "Oh, it's like 52%." And I'm like, "Dude, like you can't ask for more. In fact, you can actually probably raise up the temperature and you'd still be comfortable." So it does matter. Like it really does matter on how they're dealing with it.
But Bob Kelly has a good comment that code officials need to understand that if you have accident do I when doing a plan review to create a good envelope. He wants to know if there's any online videos for code official training. So that's the other missing link in the puzzle, or the architects or designers need to know what to do, the installers need to know what to do, and then the inspectors need to know what to do. And we're lucky if one of those 3 people actually understand water and moisture management. I wanted to, or going back to the previous topic, I wanted to make a plug for a friend of a lot of ours, Dan Morrison, runs Pro Tradecraft. He actually makes videos specifically to address the non-English speaker population, or they're for everybody. Ben's done a lot of them. They're for everybody, but he specifically does videos to sort of get around the language barrier. So that's one approach, is just don't use words, just show pictures.
Yeah, so I always argue, you know, so a little bit of a plug. LP's coming out with a gasket system, right? We're going to work on an air sealing gasket system that framers install. Because once again, when I'm looking at a building, we do really good with field products, right? We tape, we cover. We never look at how it terminates at the bottom plate or at the top plate or windows, right? So we're going to be developing a gasket to help air seal. when we're talking about this gasket, we're going to be working with, influencers, as you guys have seen, right? The Mexican carpenter is going to be huge in that Latin group that watch him. All the other R&R and AFT, they'll be great, but I'm all about making sure that everyone needs to know, including inspectors, because it's going to matter how they understand and how they interpret our products. So that's a great call out. I'm going to make sure on our next meeting, I'm gonna put that on top of our list to do.
And be sure you drive home the importance of the why with that. Like, that's really what drives it home for our crews when we're training guys in the field, is not just showing this is very specifically how you do this, even words, no words, but quite literally. And here's what it looks like when you fail to do this right. Here's the water in the basement. Here's the mold on the wall. Like, these things are a direct result of failure to pay attention right now and to do it this way from now on. And if you raise the stakes for them in that moment, it can usually take hold, and it's a lot more productive for us.
Yeah. So I always go back to when I work with installers, showing them, especially piece rate ones, showing them if you fail to do it right because you wanted to rush 5 minutes, you have to come back for about 2 hours between driving to the location, finding what you missed, fixing what you missed, and then leaving. And that's out of their pocket. So I have no issues bringing that up.
We do it nice because we do it twice.
Yeah.
Well, to pull at the heartstrings, I usually try to talk more about like health outcomes, because a lot of times the guys that are on the job that day, they're not thinking that they're necessarily going to be in the same career in 5 years. So they're not thinking about their long-term liability. But if you can connect it to, a health outcome for the little old lady or the little kid that's going to sleep in that room, and now you're talking about mold spores, and now you've given someone childhood asthma because you didn't do your job well or pay attention during this video, usually you can get someone who's, a tough guy and, I'm gonna be at the lake this weekend. I'm not sweating this. I'm thinking about the beers I got to pick up on my way back. That's a different guy anyway, who's hard to win over. But if you can get him thinking about his kid and his kid not being able to play football because he can't breathe right, then all of a sudden you can drive that point home and make a big difference in what that guy's work will be from there on.
That's a great point, Travis. That's a great point. Yeah. And then adding to that, I like calling them IKEA pictures. So I'm a big fan of building these one-sheeters that are basically nothing but pictures and arrows where things go, because it's easier. You don't need to worry about who's speaking what or who understands what, as long as they understand the nail goes here and the sheathing goes here, and here's the arrows where you need to install it.
Yeah. All right, Neil, I got one for you. So what's the most common moisture related failure that you see sitting in a manufacturer's procedure?
So depending on what hat you want me to wear, from like an OSB hat, the fact that people do not give us that 3/4 inch requirement of slab and OSB drives me up the wall. They love sticking it right onto the slab on grade and then slamming it right next to the sheets, right? OSB, plywood, any sheathing typically has to have an expansion contraction joint. And that matters, right? We're adding capillary effect, capillary being the way the water can pull up into the board for people who aren't familiar with that term. And then the expansion, thermal expansion in both directions, right? Well, all 4 directions of a sheet. And they like slamming it. So when we talk about, nail pops or like finished things inside, they're being affected because the outside of that wall is twisting and heaving against itself. So how
about from the OC end? What was the most common moisture related issue you saw?
Lack of proper air sealing. Air sealing was one of our biggest issues. So I would go out there with cans of 1 part can foam, caulking, and I would literally walk through people on how to install the product, where to put it, why to put it. And we would hit those emotion parts. We would talk about the mold, we would talk about the risk. And the fact that it takes that to convince someone to do it right always kind of irked me, because you think it's like, hey, as a homeowner, I'm buying the right product, but it's just not being installed or inspected properly. And that's where I always have like a disconnect between what is right for the homeowner versus what is right for the guy's pocket, because that's what he's getting paid to do. Right. So it's always a fight, but honestly, air sealing, which I feel is really easy, is not easy for most people. But they don't see it like I do. I see it as air being a liquid, and it's going to be a pipe. It's going to leak wherever there's a hole, and that's it. Other people see it as, someone else will take care of it.
I think the continuity is always the trouble. Like people get it in, like you were saying earlier, you know, oh, I know how to put up WRB. I just do this whole wall. It's like, well, yeah, that's the easy part. And then let's figure out how we're going to deal with this corner at the window and where are you going to connect it to your control layer at the top? How's it going to connect to the sill? Your issue at the slab, all those things. It's the connection points and the continuity is what vexes people again and again. So focusing on the nuances. And frankly, this is one of the things that I think gets us in trouble when we do deep dives into vapor. I think that people that I encounter in building science love to talk about vapor because there's the most to talk about. It's one of the more nuanced topics. It allows for people to have a distinct point of view that's affected by climate, and you can get into elaborate wall assembly details that involve all these different materials, and you can get a smart vapor barrier, and you can do all sorts of really clever analyses. But what it really comes down to in terms of what we see in failure is a very, very small part of our problems in building. And, you know, to your point earlier, most of those problems are bulk water problems. The vapor is an after effect. You know, the solar vapor drive that Mike was talking about, I've seen one example of that maybe in my career, and I've done a lot of crappy fixing of things that had to be fixed because there was bad things done earlier. So there's a lot of problems out there that we can really solve with bulk water management, and we don't want to talk about that because it's a $5 piece of flashing that would solve that, or, you know, somebody trying a little bit harder with a little pook heat in the right place, right?
Yeah, so solar vapor drive is a slow process. Yes. The accumulation for damage is anywhere between a 15 to 25 year issue. And when I was working at Owens Corning, I would get called by a lot of our insulators being like, hey, look, you know, this vaulted ceiling, they painted it a couple times, they keep getting mold. And I'm like, tear open the ridge, you're gonna see that there's wood blocking that soffit, that, you know, the baffled area, and it's blocking that moisture from escaping. That's why you're getting that condensation there. And sure enough, you know, I've had people on phones going, oh my God, that's all it is, after they open up the wall. And it's like, I've been dealing with this for, you know, 5 years now. No one has been able to solve it because they don't realize that that's what it is. But it's a slow process. Bulk water's fast, right? That's the issue. Is the reason why we see bulk water so often. It's a fast result. People see it, they see dripping, they see discoloration, they hear, you know, they smell it. Vapor drive is slow. It's so slow. And for it to actually accumulate and cause damage, it's a long process.
Jake Bruton sent me a message a number of years ago asking if I had ever seen a purely vapor caused failure in a building. So not something that was the result of poor bulk water management or poor air sealing, but purely vapor. And it took me a little while. And the only case that I can think of is like structures in very old buildings in basements with dirt floors where those structures started to fail because of vapor drive. And that took something in the order of like 200 plus years for that to happen. So just bear that in mind, like vapor is, stop worrying about vapor. Yes, but no, right? Yes, because yes, it depends.
Yes, so it depends on your climate zone, right? In a hot, humid climate where you have sun driving in that heat on black shingles, you may see it in the future. It won't be instantaneous. I saw somebody comment, bulk water is a pass and fail, and that's the point, right? You see it, it's failed, fix it. Vapor, you don't know, and that's why it's a tough situation when you're talking about that section of moisture. Is it's invisible. People feel it, but they don't see it, right? So it's a tough conversation with some builders, because I always tell them, I go, hey, look, you take care of this, you're going to take care of the home a lot longer than if you just, you know, if they're going to spend that extra $2,500 on upgraded cabinets, right? Put it on the envelope, because no one tears down their envelope because they choose to reconfigure their attic, right? No one does that. No one removes the gypsum. No one pulls out insulation every 25 years to re-put insulation. They'll change countertops 10 times in that, in that span of a home's life before they even look in the wall.
John Snell has asked a couple of times to discuss roofs. I know we love talking about walls because I don't know, we just do. But what are some important things to consider when it comes to roofs? Ones I think about are venting versus not venting, and then another that I think people don't understand is that roofing underlayment doesn't need to be vapor permeable because there are almost no roofings that are vapor permeable. So if the roofing isn't vapor permeable, it doesn't matter if your underlayment's vapor permeable.
Is this question specifically to me or just the panel? Because I have thoughts. I have thoughts.
Yeah,
Jump in then. You're talking. Go for it.
Mhm.
Sure. So I'm going to combine it with energy, right? Energy is going to an unvented attic. While there are other systems out there, and I believe in those other systems, I've helped develop other systems like buried ducts. I published a paper with Joe Steve, Rick Achilles, Mika Salanovada, right? So I published papers on buried ducts and the efficiencies of it. I don't want to fight an uphill battle convincing people to change their system. What's going to happen is we're going to move to an unvented attic system, whether I like it or not. And what I want to do is I want to change the way we think about attics. I'm great with encompassing attics, but
let me interrupt 1 second, Neil. Why are we going to move to an unvented attic?
Sorry, in hot, humid climate zones where units and ducts are in the attic. For everybody up north where your stuff is in the basement, ignore this. You're fine.
You made me nervous as a northerner. I'm like, what do you mean you're coming for my attics?
No, I always think of building as a majority being that, that Southern smile still to this day. But when I'm talking about attics, I'm fine with an unvented attic. I'm absolutely fine with it. I think they're a great performing home if it's done right. If you move air in it, I'm a big fan of putting a supply air duct into an unvented attic. Moisture stratification is real and it will penetrate that foam, especially at the ridge. I've seen it personally. But also, people forget that they're dealing with a complex issue. When you spray foam roof decks, you typically lose shingle warranty, especially composite shingle warranty. So I'm trying to move to a unvented attic where we vent the deck with a baffle from soffit to ridge, and then you can spray foam where you can seal properly. It doesn't have to be spray foam. That's what market's doing. So I'm saying spray foam. You can do a vapor, a permeable product, fiberglass, whatever you want, cellulose, rock wool, all the way up, as long as you have that vapor barrier, some sort of poly to prevent condensation. So if it condensates on the roof deck, drips down to this, can drip out. So as far as assemblies, I'm going to say this very carefully. It depends on where you're built, because every area needs different things. So if I'm suggesting something, know that I'm going to have to tell you the climate zone. So like in the South, a lot of people are using Tech Shield or some sort of radiant barrier sheathing there. So you can't put spray foam there. This where that baffled system, Tech Shield works great in a lot of climate zones now. If you're going to do that, I always recommend people to go past the minimum requirement by SPFA. So SPFA likes to say we are a vapor barrier, an air barrier past a certain thickness. Make sure you do that. It depends on the foam, it depends on the manufacturer, so I'm not going to call out any specific depths. But I always recommend going past that air and moisture barrier if you're dealing with attics, and then of course controlling any vapor that leaves through that gypsum ceiling by moving air. As far as the underlayment, you guys already said it. All the things are pretty much vapor impermeable. It doesn't matter, and heat moves really fast to dry a lot of that stuff, unless it's a big drip or damage. So roofs are hard. because if it is a actual true vapor issue, you may no longer be building in that area for that house anymore, and they may not be under warranty. But on the other end, the homeowner is going to have to be dealing with it. So I'm a big fan of ventilating roof decks because if vapor does happen, vapor can escape. I'm happy to recommend some diffusion ports. I'm happy to recommend actual ventilation, mechanical ventilation, passive ventilation. It's more about air, in my opinion, on that roof, under roof deck, to prevent any issues with moisture. And I'll shut up. I'm sorry.
My going recommendations right now is I will always recommend a ventilated roof deck situation. It can be a sealed or unsealed attic, or a sealed attic, ventilated roof deck, unless you're in a wildfire area. To me, the ventilated roof assembly is always going to be the safest assembly. Stebrick's kind of pivoted on this recently, which I don't totally understand why, but I think it's related to wildfires. So always ventilated roof deck situation, unless you're in a wildfire area, then by all means go unvented with spray foam to the bottom side of it. But also to your point there, Neil, you made, we've to some degree been sold a bill of goods with spray foam. We like to bang on spray foam here, so I'm going to take my soapbox for a minute. We're seeing failures in roof assemblies where they're applying directly to the bottom side of the roof because it shrinks, it cracks, it thermocycles over time, and you end up getting moisture deposition on the bottom side of that roof sheathing, and then you end up with a ridge, which is oatmeal after a handful of years. So it's just too risky. It's always going to be safer to vent the bottom side of that assembly if possible.
And I'll say that, or that's essentially where I've seen water vapor failures is actually in SIPs multiple times. I've seen ridges rotten out from SIPs. I've seen walls. I've replaced skylights. I've seen windows rotted out. I mean, you can call it condensation if you want, but it's condensation of water vapor. So if the vapor can condense, then it can cause problems. Neil, I have an LP related question, which is I still hear from people who are nervous about using LP Smart Side because there were some failures of the 1990s version. What has changed, and why is it a great product now, or is it not a great product now? I'm assuming I know your answer about the current product.
2023.
Yeah. So
I just ordered 4,000 square feet of it this week. So
yeah. So one of the things that I want to say is we jumped onto building envelopes with composite material without understanding physics. Like without a doubt, like that itself is why buildings fail, right? You guys have mentioned it before. We solve a problem to create another one. Like we're really, really good at that. And I've always told people, I'm like, if you don't think about the whole thing as a system, right? Once you enclose that envelope, it's no longer components. It is a system. Once you enclose that roof deck, it's a system. It's not components. Components may fail, sure, but it's working as a system. And the other big issue is chemistries have improved, resins have improved, right? Technology around our paper that's over, a lot of that product has improved. That paint has improved. Things have gotten better. I actually like the way our product looks a lot. The board and batten look is becoming real popular, so I'm a big fan of it. The only thing is I do want to tell people, if you decide to go with a black siding product, please ventilate. Put a rain screen. 3/8 minimum. 3/8 minimum. That's all I ask for, because whatever you put underneath it, it's going to get hot.
You can just make that a universal rule. Rain screen everything. Like there's no downside.
Completely agree.
Sorry, Ben.
Yeah. So why the 3/8 minimum, Neil?
That's to prevent any capillary, right? So at anything above 3/8 and above, water can't tend to crawl on both surfaces. It can't exceed the atmospheric pressure, right? So anything tighter than that, excuse me, beer.
It is BS and beer.
Yeah, we're used to it.
So like a lot of there's a lot of great products. I don't want to call anybody by name, but there's some sort of crinkle wrap stuff out there. There's some sort of little nodules that are well within under that 3/8 gap, and water can climb. And once again, when we're dealing with moisture issues, and if you don't provide the right water control at the connection between floor to crawl space to cement wall, right? I mean, you're dealing with water that can climb up, and water likes to climb if it can.
So Straub's current research is showing that they're walking back that 3/8 of an inch and going back down to a 1/16. And he's showing that he's seen similar draining capacities at a 1/16 of an inch as they previously had seen at 3/8 of an inch. But the thing that they don't see at those small sizes is the drying potential.
Yeah, air movement.
Equivalent drainage.
Yeah, it also promotes the air movement, and that's why I'm still a big fan of that 3/8 gap. I've actually seen some of the studies that John Straub's talking about. I'm on a bunch of ASHRAE boards, 160 for modeling, 4.4 for wall performance, 4.7 for energy, right? So like I'm in this world, whether I like it or not, I'm in it. A little too deep sometimes, but you know, when we talk about how a wall performs, I like passive safety, and 3/8 is a great measurement for passive safety in walls.
You're preaching to somebody who still suggests we go 3/4 so that we get better convective air movement.
I mean, you know, there was a company like 5 years ago who had a mechanical in-wall ventilation system. I don't know if they exist anymore. I don't know of them, but they had like fans inside wall cavities to move air.
That makes me nervous.
Yeah, but
As long as they're inboard of the continuous exterior insulation and air control layer, I guess you could do that, but it seems unnecessary at that point.
I think it was more for commercial buildings, tell you the truth, but it exists. They want to move air, and that was their goal.
Or we are pretty much at time. Why don't we go around the horn and everybody tells us their favorite water management trick. I'm going to start with Emily.
You're gonna start with me? I want to go last. My favorite water management trick. I think I showed my cards earlier on when I talked about adding QR codes to the drawings, because I definitely think that I've learned as an architect that our clients don't understand the drawings that we do. And so also I think in the field, sometimes a 2D drawing is not enough information to get you what you need to know to do that. So my trick's going to be to start adding the QR codes to it, because I don't physically put stuff up except for at my own house. So
Sounds good. How about Travis?
I keep it pretty simple. My favorite water management trick is pitching sills, not with a 5-degree cut on your cripple studs and an elaborate back dam with 3 parts and an extra lead pan. I whack it with a hammer, and then I stick a shim in between the cripple and the sill, and it drains out. So it costs nothing. Whack it with a hammer. That's my tip for the day. Hit it with a hammer and make sure that you're hitting it from the inside of the window and not from the outside, which is harder with the sheathing on, I think, anyway.
Right. How about you, Ben?
I'm a big fan of gaskets. So Neil, it was interesting to hear you say that LP's headed in that direction, because it simplifies the process of flashing and air control for the trades. We no longer have to rely on, special techniques and learned knowledge and application. You just take something, stick it over it, and you tape the 4 sides flat, and it's done. So big fan of gaskets.
Nice. How about you, Neil? Gaskets?
So Travis took mine, and then my second was going to be what Ben said. So I'm going to go with application. Fast is fail, slow is right.
All right. I think mine is kick-out flashings. I've renovated or designed renovations on hundreds of projects, and it's the one thing I've never seen a house that didn't have kick-out flashings that did not have significant water damage where there should be a kick-out flashing. So kick-out flashings is my vote. I want to thank Neil for joining us, and everybody else on screen, and everybody in attendance. This was a really fun, fast-paced conversation that we didn't get to a lot of topics, but come back next time and maybe we'll hit them.
Yeah, sorry about that. Thanks, everybody.
Great job.
we can do a
Thanks,
whole
Neil.
year on moisture management.
We'll see you again. Thanks a lot.
Thanks
Bye,
for joining us, everyone.